Hello, Year 9. Right, okay, so our new unit is back to some chemistry. So you've got a bit of a recap quiz there, all about states of matter. So when we talk about states of matter, we're meaning whether things are solids, liquids, or gases. So you need to answer those questions, and then I will give you the answers tomorrow. Okay then, so in terms of what everything is made of, in chemistry, everything is made of atoms. That's the smallest thing that we describe, okay? And elements are made of one type of atom. So all the elements are listed in the periodic table, and if you broke those down into the simplest, smallest particles that you could get, then each of those particles, each of those atoms would be exactly the same. So copper is made only of copper atoms. Carbon is made only of carbon atoms, and helium is only made of helium atoms. Now what you'll notice in the circles is that the copper and the carbon, okay, are both solids because they have that arrangement where they're in neat rows, they're all touching, they're all stood really, really close like soldiers, okay. The helium, the particles are spread more far apart because helium is a gas, okay. So that's another thing that we need to remember, another bit of a recap. Now, in terms of getting different products, so if you think about cheese as just a daft example, there's lots and lots of different types of cheese, and each one of them tastes different, it has a different texture. Some of them are quite soft, some of them are quite hard, okay? And when you make cheese, they're all made using milk of some description, whether that's cow's milk or sheep's milk or goat's milk. But we can still end up with lots of different types because we put those ingredients together in different recipes, in different orders, in different quantities. So just the same way that we use the same ingredients, the same basic ingredients to make all these different cheeses, all compounds, all chemicals are made from elements that are joined together in different recipes. Okay, so we've got about 100 naturally occurring elements, and every single substance on the planet is made up from different combinations of these elements. Okay, and that's how we end up with different compounds. Now, we need to think what compounds are, okay? So compounds are when elements are joined together, they're chemically joined together. So in this case, you've got water, and it's consisting there of hydrogen, which is the H, and oxygen, which is the O. And you'll notice there that you've got 2 hydrogens and only 1 oxygen. So the formula for water is H2O, and it's a small number 2, you'll see some in a minute, to represent that there's 2 atoms of hydrogen, okay? This is carbon dioxide, so again, you've got 2 atoms of oxygen joined to 1 atom of carbon, okay? So the formula for that would be CO2, because the 2 is telling you how many atoms of oxygen that you've got. Now we need to try and figure out and decipher what these formulae mean, okay, and how compounds are actually made up. So if you have a chemical reaction that forms a compound, you get different clues as to there being a chemical reaction. Okay, so you might see a colour change, you might see a precipitate. So sometimes you add 2 liquids together and it will form like a jelly. That's called a precipitate. You might see energy being produced. So it might fizz, it might give off some steam, it might get warm, it might get hot, it might get cold. Okay, so changes in energy are a sign that a chemical reaction is happening. You might notice a smell. So all of these are clues that chemical reaction has happened. Okay, so you've made a compound. Now, in terms of naming these compounds, normally we can have 2 elements joined together, and we change the end of the second one to IDE. So in this case, I've got magnesium and oxygen. Now, normally when we name things, the name of the metal goes first. Okay, so in this case, magnesium is the metal, that goes first, and then the oxygen becomes oxide. So I've joined together magnesium and oxygen, and my compound is called magnesium oxide. Okay. In this case, you can have a go at some of these. You can pause the video and have a go. So for the first one, again, you've got sodium and chlorine. Sodium is the metal, so that would go first. Chlorine is the second one, so that gets changed into the ide. So in this case, you'd have sodium chloride. Now, the others follow the same pattern. Just be careful with number 4, okay, because of the order that it's written in. Think about which one's the metal and which one's the non-metal. And also number 5 as well. And if you want to have a go and challenge yourself at 6 through to 10, you'll need the periodic table that's in your planner to try and find out what elements these are. Okay, so we're starting to think about the formula rather than writing out the long name, because scientists are a bit lazy really, we don't like writing too much. Rather than writing out the long name, we can use the formula instead. Okay, so have a go at those, and again, I will give you the answers tomorrow. Okay, now, if you get 3 or more elements that combine, so these ones that we've looked at first is 2 elements. If you get 3 or more elements that combine and one of them is oxygen, then the oxygen makes the ending into ATE. So again, we put our metal first, so that's copper. I've got sulfur, and then the oxygen makes that end an 8. So I've got copper, sulf, 8. So the copper, and then my sulf comes from sulfur, and then the ATE comes from the oxygen. So there's some more examples to have a look at. So you've got calcium, carbon and oxygen. Calcium is first because it's the metal. So it'll be calcium, carbon, 8, because the oxygen becomes 8. Okay, again, you've got potassium, carbon, 8. Okay, so again, have another little go at those, and then there's some with the formula that you can try. Okay, don't worry too much about the numbers for the time being. Just try and identify what the symbols of the elements are. Don't forget, if it's got a big letter and a small letter, it's the same element. Okay, so in the case of number 6, AG is the symbol for 1 element, not 2. Okay, then you've got N as a symbol and O as a symbol. Right, so we need to think about what these formula are telling us. Okay, so in a compound, I've picked one here that's a straightforward one. Sorry about that. We've got calcium carbonate, and it's got the chemical formula CaCO3. Okay, now we need to be able to decipher what that actually means in real life. Okay, so Ca, because it's a big letter and a small letter, is 1 element, and I can look that up in the periodic table, and that will tell me that it is calcium. I've then got a big C, so I look that one up again because it's 1 letter by itself, which will be carbon, and then I've got O, which is a big letter, which is oxygen. Okay, so I can identify those 3 symbols. Now, what we need to think about is the numbers. So now that we've identified what the elements are, we need to think how many there are of each one. So at the moment, I've got calcium with no numbers next to it. So that means I've got 1 atom of calcium. I've got a C for carbon with no numbers next to it. So I've got 1 carbon atom. Now oxygen, because I've got that lowered number 3, that tells me that I've got 3 atoms of oxygen. So the 3 only relates to the letter before it. Okay, so I've got 1 calcium, 1 carbon and 3 atoms of oxygen, and that's what the formula mean. Okay, so that's the same answers. So in this case, you've got some more examples. So we've got MgO, big letter and small letter is the same element. I've got no number, so it means there's just 1 of them, and I've got an O for oxygen. So I've got 1 magnesium, 1 oxygen. For HNO3, 1 hydrogen, 1 nitrogen, 3 oxygens. Okay, so have a little read through it. It is quite straightforward. The number relates to the element before it. Now, in this case, what you're going to try and do is try and write the formula for these named compounds. Okay, so what this is doing is kind of looking at it from the other way, from the opposite sort of side, and saying, right, well, if I know these are the atoms that I've got, how would I write it? So for every silicon atom, there are 4 chlorine atoms. So what you're going to do is you're going to have to look up silicon to find out what its symbol is, and you're going to have to look up chlorine to see what its symbol is, and then we need to put the numbers in the right places. So for the first one, I've got 1 silicon and 4 chlorine. So silicon is Si, and it's just 1 of them, and then chlorine is Cl, and there's 4. Now you have to make sure that that number 4 is lower down. Now I'm going to stop the video now, because what I want you to do is I want you to have a go at these other 2, and if I carry on with my PowerPoint, it will give you the answers. Okay, so that's what you're going to do, and I'm going to put 2 other sheets onto class charts for you to have a go at working with these formula and deciphering what is in different compounds.